to understand the future of the auto industry, then we're going to have to look a lot further than just technology. And that's the problem of the manufacturers right now. They are taking huge technology bets. I'm going to take you into a whirlwind tour of some of these technology bets. Many of them are going to fail. You know why? Not because of legislation, not because of cost, but because of emotion. Imagine a Harley Davidson going down the road with an electric engine in the back. I mean, what is Harley Davidson about? Harley Davidson's about something that triggers passion. And just like auctions are something to do with theater and energy and experience and being caught up in the moment, being part of a community. Emotion is what, of course, creates the brand affinity of the future. It's something to do with coolness, attractiveness, the must-have. Now, here is another huge trend, which is nothing to do with emotion, but is also going to drive the future, and it's, of course, demographics. And when we look at demographics, we're going to see another massive challenge for the auto industry, because although they do know where this one's going, they don't know necessarily what it means in terms of emotion. Let me explain. There are 1 billion children alive today, more than there's ever been on Earth at any point in human history. And all of them will be adults soon. All of them will want to own cars. And where will those children be? A huge number of them are in Asia. And of course, that's part of the reason why we will see 40% of the world's GDP in Asia next year. It's why we will see this profound realignment of global power. You know, 300 million people are going to walk out of a world of horse and cart and toiling the soil in rural parts of China. And they're going to embrace the busy metropolis of Shanghai or Beijing or Kunming or something like that. And a similar number, 475 million others, will move from remote rural lifestyles in Africa to great big places like Lagos or Nairobi. And as they do, they're going to want transport. They're going to want their cars. And if we had the level of car ownership globally the same as it is in this country, we'd have 4 times as many cars on the roads, and that could create other problems too. But I'll come back to that in a moment. If we look at where, this is the car manufacturers' world, if we look at where their future growth is going to be, they say, forget the US, forget Europe. It's over. Australia, it's finished. We can sell them new technologies, we can reduce carbon footprint, we can do other exciting things, we can improve the customer experience with gadgets and widgets and the rest. But volume, folks, if we're going to go for growth, it's got to be Asia. Now, the reason why this matters to you is because it means, you see, the world is so small, it can only afford 5, 6, 7, or 8 big car manufacturers. It takes billions of dollars to develop one new model. You can't just develop a new model for China. So you can see a huge thrust in terms of seizing market share is going to be to fight for Asia, to fight for Africa. And no one's quite sure what kind of cars those will be. Now, if we look at car sales, therefore, by 2020, I'm expecting to see car sales up from 80 million or so to 107 million. So a big, healthy picture globally, but it'll be relatively flat in Europe with some recovery here, which is catch up because obviously we had some quiet years. But are there limits to car ownership? Well, if you live in some places like Delhi and things like that, or Nairobi, you might certainly think so. I want to come back to global manufacturing scale. We're seeing this global consolidation. So the UK has never made so many cars as today, but hardly any of them are owned by the British people. They're bought, but the companies that make them are foreign. Charter Groups owns Jaguar. Russia will be the largest car maker in Europe. And yet, at the same time, we're seeing car making move into places where those cars are going to be sold. So Indonesia, Brazil, Turkey, and so on. We're seeing massive investment, of course, in robotics of every single kind and new kinds of engineering. We're seeing common platforms. This is nothing new, but more of them. So the VW mega platform was going to be a basis, I think, for at least 1 million cars. They won't look the same. They won't be owned by similar people. They'll go in different directions with different customer experience, but look beneath the bonnet and you notice it. It's exactly the same car. And at the same time, we're seeing all kinds of contractions of supply chains. So that we're seeing regional hubs for manufacturing, huge growth in component trade. We're seeing parts and components moving around in particular regions and then being assembled together. A car built from pieces from around Asia into a car that's made in China to be sold in Vietnam. Now, at the same time, which is good news for America, jobs are coming home. All kinds of manufacturing jobs coming back. Why? Because China is so incredibly expensive. Last year, I can tell you that prices in China were 12% cheaper. That's a lot difference. So if you have outsourced some jobs to China, in 2 years, they're 24% more expensive, or so 24% more expensive than 24 months earlier. Now, you go another year or two like that, and you have pushed a huge amount of manufacturing out of business. So Mexico is now competitive. Actually, the UK is now competitive compared to Poland. Poland's competitive compared to China. It's changing very, very fast. It's a very disruptive process bringing all these jobs back home. And we're seeing manufacturers doing all kinds of extraordinary inventive things. They just hacked 40% of the weight out of a Land Rover. And nanotech coatings are here already. We were just talking earlier about nanotech paint coatings which are self-clean. Hopefully won't need any washing for 10 years. I'm not sure I actually believe it. You see, it takes 10 years to test. And they've only just brought it on the market, so you'll tell me the truth. But it will be different. It'll need less cleaning, for sure. The windscreens will be much better to look through. The optics will be tremendous. The fabrics will be air cleaning. My textile friends who are into clothing manufacturing are dreaming of new nanotech coatings on individual fibers, which means you just blow them with air to make them clean. Just think about how that would improve the inside of a car. We're going to see already, we're starting to see things like laser headlights come through, which give you 500 meters distance. We're going to see external airbags. Again, people are experimenting with these kind of things, which are interesting because they protect the bodywork from all kinds of dents. We've already seen massive improvements in the energy efficiency of trucks, whether it's the aerodynamics, whether it's new kind of tires, whether it's generating electric power for the aircon out of the suspension system. A whole host of different things which we can do, I think, which will bring that down by a further 20% without any major miracles. Actually, by the way, the fastest way to improve efficiency for trucks is to fill them. 30% of all the trucks running across America are empty. I don't know how that affects you, but in terms of auto transport, but I wonder how many journeys are made with big vehicles carrying 10, 15, 20 other vehicles on them, where in one direction they're almost empty. It's a massive business opportunity for someone. And then we come back to energy, which has been the biggest focus. How are we going to drive these things? That's been the biggest worry for car manufacturers, that they'll get it wrong, which is why we're seeing them experiment with lots of different things, and they're expecting most of these things to fail. But let's have a look at what some of them are and the drivers for it. Firstly, let's have a look at gas. You see, the shale gas explosion has meant that reserves of gas proven in the world have improved from just 60 years, 5 years ago, to 200 years in just 60 months. It's incredible what's happened. And as gas supplies have dropped towards zero in cost per cubic meter, so all kinds of people have started to think about using gas to power vehicles. And in places like India, they already are. The air pollution was so vast that the Indian government decided to pass a regulation forcing every taxi and all the buses and so on to convert to liquid petroleum gas, and overnight the air cleared. But gas, I don't see that as becoming the #1 fuel of the future. I really don't. I think we'll see experiments with it. The trouble with it is that it's bulky, and that we don't have the infrastructure to run it around through all the places where you'd normally buy gasoline or diesel. The same goes for hydrogen. Yes, we're seeing all kinds of stories which sound amazing. It's wonderful to think of a car that emits just water. Great, fantastic. Hydrogen, oxygen, just steam. But hydrogen is really expensive to move across the United States of America. It's really costly. It's an absolute fortune. Hydrogen is a very tiny molecule. It's very difficult to contain. You have the smallest leak in a pipe, it will find its way through. It's a bit like helium. I don't know if you remember as a child or with your children, you blow up helium balloons. It's hard to keep the helium in the balloon, right? However tight you get it, the helium will find a way out of that tiny hole. You fill it up with ordinary air, it'll stay inflated for months. So hydrogen is a challenge, and it doesn't mean that cars aren't being developed to use them, and we're seeing big improvements in the hydrogen fuel cell efficiency just in the last couple of years. But am I a great believer that the whole world's going to run on hydrogen? No, I don't think so. So problems with supply, problems with storage, problems simply with volume. You know, it's very difficult to run a plane on hydrogen. You need tanks the size of the aircraft. Hydrogen is a really inefficient gas. You don't get much in terms of power for every kilogram of weight. So unless people are going to resign themselves to having no luggage in the back and no spare tires, I'm exaggerating a little bit, of course. But frankly, hydrogen has challenges. So it won't stop people from losing a lot of money on hydrogen experiments. Why? Because these manufacturers are having nightmares. They're having nightmares. They're having nightmares that one of these technologies is going to win and going to kick them sideways, and they won't be ready. So you're seeing them. They will experiment with lots of things that fundamentally they're not quite sure they believe in, but they will just do it, and they'll confuse all your auctions in the process, but never mind. And here's another thing, which is, okay, let's clean up oil, let's say. Let's clean up oil. Yeah, let's have bio-oil. That's biodiesel, biogasoline. That's great. The only challenge is no one did the math. You have to use every gram, every kilogram of grain grown in the entire United States of America to drive the trucks and all the auto industry for about 25% of the miles it drives each year. And there will be no food left to eat. And as it is, with just 5% of Europe's fuel going bio, I think it's 5 to 10% here. You know what? We already produced food spikes around the world of up to 70%, according to the UN. So I'm not sure this particular policy is going to fundamentally work. We have to think differently. So then we move on to e-cars. And now we begin to understand why it is that car manufacturers have been putting so many tens of billions of dollars into one simple thing, which is the battery. The engines are simple. We've had the engines for years. And the technology is so easy. Even a child can build an electric car. You just put a little electric motor on each wheel, and that's it. There's nothing more to worry about. You just need a brake and a steering device, and you've got a car. Think of the complexity of the latest injection-controlled diesels with all the emissions technologies, and oh my goodness, this is just has to be made to work. You think from the engineering point of view, if we can just get enough power from under the seat without causing the whole car to squash the road flat because it's so heavy. And at the same time, this is being driven, of course, by relentless pressure, which has come, I think, more from the European Union than any other sector of the global market. A relentless grinding, forcing pressure to get the grams of CO2 down per vehicle. And it's come down already dramatically. 164 was the target in 2007. Now it's 95. And we're going to be heading soon for about 20 grams per kilogram of CO2. Can we do it? Yes, we can. In the same way, we've seen NOx emissions for Eurodiesel, gasoline, diesel. If you look at the US, if we look at the EU, look how dramatically these emissions controls have fallen. These regulations have become stricter in just a decade. And it was just at the beginning. By the way, if a country is really serious about cleaning up the air, all you need to do is take out the worst 20% of vehicles and be done with it. Really. The 20% of the monsters that are driving around, the old ones that are more than 10 or 15 years old, they're doing nearly all of the environmental damage, but that's another question. And VW's already done it. You know, VW's got a latest hybrid And it pumps out not 95 grams per kilometer, which is the EU today, but they've already got to 21. And we've only just started. So where does this lead us? Now, the hybrid story is really interesting. It's one that everybody gets their head around. Okay, I've got a gasoline car, a diesel car, and it's got a bit of a battery. But the big question there is, what is the point of having two entire propulsion systems? You just built the car twice. There's got to be extra cost there sometime. How can we sort this out? Especially when you look at the data. You see, the data is interesting. Let's look at GM's own data for Volt. They show that the average driver is using the battery 82% of the time, even with the range of only 38 miles on the battery. Now, if they could get the battery mileage up to even 50, that might get up to 95% of the time they don't need any kind of fuel except electricity. And that means that you might as well just plug it in. So we're not using the carbon to power up the batteries at all. We're powering them up at home, and we're just using this monstrous additional piece of metal just for the extra 5% of miles we need to do. And then, of course, someone says, hey, but many people have got two cars anyway, so why would they be wanting to use this car to go more than 50 miles without a top-up? And with the recharge being 80% recharge in maybe 1 hour, what more do I need? So, and then that's just looking at today's batteries. What about tomorrow? Some people said, well, of course, the answer is we swap the batteries out. And there was another technological disaster and investment failure when companies decided in different parts of the world to put replacement batteries in gas stations. So basically, you get the vehicle for virtually free, and then you rent the battery as you go. You never own the battery. You just turn in the station, swap the battery out, and away you carry on driving. Well, that's already died too. So you can see that the poor old manufacturers are in a mess. They just don't know which way to turn because there's a battle between all these technologies and things are getting overtaken by events. And in the meantime, there's this tricky word called emotion triggering in, which means that even when it makes commercial sense, regulatory sense, we may find that regulators and consumers go somewhere different. Now, let's go back then to the actual sales, the actual reality for e-vehicle sales in the United States. And, okay, it looks pretty good, but it's not as dramatic as it might be. We haven't really reached the point of absolute liftoff yet. Now, I was one of the first people to own an electric vehicle. It was a G-Whiz, and it was in the early days when 70% of all the electric vehicles in the world were basically like a golf cart, tiny little things, fun to drive, at maximum speed about 45 miles an hour. And if we look, therefore, at big predictions made, say, in Germany or by manufacturers like Nissan Leaf, then we can say that we're ahead of ourselves. I said to you, many of the debates about the future are not about what's going to happen, it's a question about when. And we can see, it's obvious, that the cost of battery technology is falling dramatically. It will not fall to zero because it's stuck full of precious metals. And there's a lot of component there you just can't get rid of. A lot of really, really expensive commodity goes into these batteries. But their efficiency is going to improve, the speed of recharging is going to improve, we're going to reduce the weight across the rest of the vehicle, we're going to find ingenious ways to build a battery. Battery coatings will be in the wall of the vehicle, they'll be in the steering wheel, will be battery, in the drive shafts, not quite, but in every single surface and membrane and thing that you touch, you're going to find battery in there. And it's not a question of having this big bulky thing in one part of the vehicle. This will be absolutely built in from the very beginning, a bit like a Formula One car with the way that it's designed. And just look at how cool electric has become. Who here has driven a Tesla? Anybody here driven a Tesla? Put your hands up. Amazing experience, wasn't it? I mean, wow. Whoa, goodness me. Have you ever driven one? It's weird. Tesla will take you from 0 to 60 miles per hour in about, 3.5 seconds? 3 or 4 seconds, right, in a vehicle like this. First time I sat in one, it was terrifying, okay? Because I'm so used to a bit of a delay. I put my foot down, the gas goes into the engine, it ignites, the fuel injection catches up, the computer works out, we're going. But this thing is absolutely instant. And even more spooky is when you took the foot off the brake, it knows that it needs to capture all that valuable electric power very quickly and suck it all back and put it back in the battery where it belongs. So what it does, the moment you take your foot off the accelerator, just a twinge, it starts sucking power out. So you got like 5G forward, like, woo, 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 bang, what was that? And the guy sitting next to me says, just go nice and slow. It's a different experience, but I tell you, it's the most exciting ride you could possibly have, legally on the roads today, I think, apart from a Formula One. It's a very exciting experience. These cars go now 100, 200 kilometers, 100, 200 miles without a recharge. They're recharging 80% of their power in 2 hours. We're in the first 2.5 seconds of the first hour of the first day of electric vehicles. This is like Thomas Edison's first light bulb. He's just playing. Tesla doesn't see itself as a car company, by the way. Do you know what business they think they're in? Batteries and software. They think that basically the entire Tesla experiment is just a way of flogging batteries to people who don't know they need them. Okay, that's what this is about. It's a play on batteries. And they know that when they crack batteries, they crack the world. It doesn't matter where the vehicles are that use the batteries, so long as they're paying a big royalty on the technology, they'll be doing fine. And the latest Tesla, this is a family saloon. It's looking nice and cool. I'm sure it's not quite as violent in its driving experience, maybe a lot more boring. But nevertheless, they've got the capacity to turn 20,000 of them out. You know, the technology is so simple to build a Tesla. They're building all these in a $42 million factory that they just picked up for a bargain. Really simple. And I don't know, but did anybody see the e-car formula race last week? Wow, that was extraordinary, wasn't it? And even more extraordinary was to see, well, I think the best thing that ever happened in that whole deal, the best thing that probably happened for electric vehicles so far was a massive and spectacular pile-up in the last 20 seconds. You couldn't even have written a script for it. And there's an extraordinary spinning out of this fantastically close race. And fortunately, I wondered how anybody would ever get out of it alive. But the cars are developed with such mathematical precision and genius that he walked out completely unscathed and was fine. But it showed us that electric vehicles can do it. They could take you not quite to outer space, but they can give you a ride that will rival anything the world has ever produced so far, at an astonishing speed and at an affordable price. And we've only just started. So what will happen with the next generation of batteries? And by when do you think this will be relevant? Now, you might say, yeah, I live in the Midwest, it's big distances, this is not going to work. I agree, not for a long time. But if you live downtown Manhattan, if you live here in Boston, I suspect these will work pretty well. Put your hands up if you can imagine owning an electric vehicle in the next 15 years as a second car. Put up your hands. Okay, there we are. We're seeing the market right before us. Now, how green are these things? If you're in France, you can pat yourself in the back that you're running a nuclear-powered car. Okay, why? You can't help it. 70% of all the juice you take from the plug comes from nuclear. So if you plug your auto into to charge your battery, then 70% of your power is nuclear power. But if you're in India, then 90% of your power is incredibly inefficient, dusty, old-fashioned old-fashioned coal. So very inefficient in comparison. But in future, we could have a 0-gram car. How can we do that? Well, we could do it by solar. I don't mean this kind of solar. This would take us quite a while. But Ford is already experimenting. This may seem a little bit far-fetched, but actually this could go into production tomorrow. The technology is here. You have a focusing device over the car, which collects sun from quite a large area and just directs it as a beam. It's just simple mirrors, if you like, onto the top of the car, where all of that light is taken. Excuse me. There's a very intense blast of energy to power the car up. And you can do, so long as you're not driving it during the day, then you can charge it pretty rapidly. Is that going to work? No. I think it's another technology which it's just a nice idea, a nice experiment, well done. 4 out of 10 for initiative. But you ain't passing the exam, okay? And now we'll come back to a bit electric, just to remember electric for a moment, because I do think it's a very, very interesting area. Now, when it comes to design of the outside of a car, actually, manufacturers are pushed into the same place. When we're talking about the inside, they're diverting all over the place with electric and hydrogen and solar and goodness knows what else. But outside, they have constraints imposed on them, which are the laws of physics. Because every wind tunnel forces us to the same conclusion, which is that all cars need to look the same. Which is why, actually, when you look at an auto auction, you can line up 50,000 cars in a lot. And quite frankly, the amount of difference between one saloon and another is getting pretty small. And that will continue to be the case for the next 10,000 years. Because of the laws of physics, right? Now, you might come to a point where actually energy is so free, we've cracked the whole solutions to the world's energy systems, that we couldn't care less about wind resistance. But so long as we continue to care about efficiency, then vehicles will all look the same. And the other reason they will continue to look remarkably similar, which is kind of bad news, in the olden days, if you think about all the wonderful classic auctions you guys ran, the most beloved car that we've owned was a 40-year-old MG. I loved it to pieces until it kept on breaking down, sadly. But I loved it. Why? Because it was built as an act of beauty rather than as by a computer in a wind tunnel. But the other limitation is human beings. There are literally only so many ways. I can tell you as a physician. I'm a physician in my first life. I can tell you there are only a certain number of limited ways that I can contort your arms and legs and squeeze you into a metal box. Even if I make it a plastic box, you don't get changed. You are still the same shape, sadly. Okay? And it does, and all human beings have got 2 arms, or nearly everyone, got 2 arms, 2 legs, we've got hands, we've got a back that needs support, and we've got a head that needs safety devices. We are stuck with a seat, probably, unless you want to stand in your car to go to work. So that means that, strangely enough, the cars that you're going to be auto-auctioning in 35 years' time, your grandchildren are going to look at and say, hey, you know what? It seems to me that for the last 30 years, we've seen very little change in shape, inside or outside, compared to the previous 30. We lost a few steering wheels along the way, but that's another story. Now, there's also, I suggest, quite a few limits to cockpit design. I mean, how many devices do you kind of want in front of your eyes as you're driving along? And actually, the trend is probably it's all going to be on a mobile anyway. Everything you want, it'll be heads up on the screen. Whatever heads up on the screen is on the mobile device, and that's that. If it's heads up on the screen, there isn't anything on the dashboard. Well, how incredibly last century it is to have lights and pieces of data flashing out of pieces of plastic. You just put it in the window where you look through and you see what you need to see as a heads up. Now, coming back to auto, it's interesting. If you look at America, there is some degree of concern about getting into a Google-driven car. If you look at India, much less. If you look at Southern Africa, much less. The people in the UK, terrified. Okay. So it seems that the more developed you are, the more emerging you are, is a big, big change in terms of acceptance of this stuff. Now, I just want to go through the creeping automation because it's happening actually at astonishing speed. Whether it's auto parking, safe distance on highways, auto braking, reading speed signs. We've already seen auto parking in a whole suite of cars. It's going to be very difficult to buy a car that doesn't know one end of a parking space from another. We've got cars which are already predicting driver mood. They know that every morning you get out the auto, you fill it with 2 children. They can see the children getting into the car. They know which seats they usually sit in. They know that you usually put the radio on Disney on the way to school, and on the way back it changes to the news. They know what ambient temperature you like it front and back. They know how long you like what speed you like to drive. They know your usual route, even though they think there might be a quicker way, but you never agree with the sat-nav, never mind. Okay, they learn all of that. So the car learns. So you get in, turn the radio onto the right channel. It's already checked the route for that particular route. And it's not going to send you the route that would be the fastest one because they know that you don't like that route. The car never understood why you don't like it, but maybe it's more scenic or something. But anyway, so they've given up trying to suggest that route. They've checked the normal route that you drive, and they can see there's some traffic on it, so they've let you know, and so on. Cars already been designed, for instance, which work out that, okay, you're down to your last 5% on the hybrid battery, but hey-ho, you're only 600 meters from home, so what? So enjoy the big blast on the accelerator, and I'm not going to turn the engine on. Intelligence, learning. The ability to detect a drowsy, drunk, or distracted driver. How do we do that? Well, alcohol in your sweat means that we can detect it on the gear lever. Bloop! Just cut the thing out. You are well over. Okay. Erratic driving is easy to detect. We know where the vehicle is. We can detect, even the iPhone can tell how hard you're braking. The LED detection shining into your eyes to see whether your eyes are nodding off or that you've been looking far too long at the other car that's a bit newer than yours out the right-hand side. Detecting heart problems, automatic ECG readings continuously happening from both sides of the steering wheel. These things, I'm telling you history. You tell me the future. Now, these kind of things are filtering in. They're going to come. Why? Because, well, I've told you why. You need to feel sorry for these car manufacturers. As you've discovered, all the cars look the same. They're all designed by computer in a wind tunnel. The engines are perfectly optimized. They've all got air conditioning, automatic locking, airbags. They've all got nice Boss speakers. They've all got, randomized computer adjusted suspension and goodness knows what. They've all got self-cleaning windows and self-cleaning floors and goodness knows what else. And how on earth can we make a car that actually feels different? And how can we emotionally engage when someone says it's only a box like all the others? And so we're going to be concentrating on all kinds of gadgets and widgets and widgets and bits and bots and other things that make people feel our car is as cool as an iPhone. Well, it's worth a try. Because what else have they got? It's a struggle. So you're going to see a boom in stuff that the regulators are also excited about. A boom in connected car sales. Yes, of course, and every car goes online. Yes, of course, every car already is online, the new ones just about. It'll be impossible to buy a car that isn't online all the time. And with the online, then there'll be a whole set of apps which are fixed to that manufacturer as they try to pretend that they are the iPhone of the future when it comes to cars. So you've got Chevrolet and Volvo and all the others. And meantime, you've got non-manufacturers that are also trying to say, hey, you know what? Just buy the box. It's us that makes it cool. So all they want from the car manufacturer is the iPhone plug-in socket. And let iPhone run it for you. Or let Google control your world. And this is a big issue. And I promise you, those Google Auto teams are thinking of all kinds of strategies to make life really tough for manufacturers. And at the same time, all kinds of other interfaces offer advantages. So we have insurance companies that are already in here and in the UK, for instance, varying their premiums depending on how fast you drove home last night. We have companies that are varying insurance premiums each day depending on your driving habits over the previous 7 days. And they're keeping a log of each person who drives, which is the only way my son can afford to buy a car, because he's going to have telematics in the car, so he can prove that he's the safest 25-year-old in the United Kingdom. Okay. And it's happening. And I think it's a jolly good idea. You could say there are privacy issues here, because the police can get hold of the data. They can see, how fast do you usually approach that corner? You spun off it last night at 35 miles an hour, and you said, oh yeah, it was a wet road and there's another car coming. But actually, we say there was a speed limit on that corner of 20. Number one. Number two, we can see that on 45 occasions in the last 13 days, you went around that corner at 45 miles per hour. Number three, we can see that over the last 6 months, your driving habits have deteriorated, sir. He said, it's my son. My son, he keeps impersonating me and entering my PIN number. So we're in an interesting place. Big brother, you could say. Now, when you connect cars together physically, then of course we get amazing savings, and we've already known that for a long time in trucking. Well, we can do it by tailgating electronically. Yes, it's already here. And I think we're going to find the National Highway Traffic Safety Administration makes it absolutely a requirement. Vehicles talk to each other. Every vehicle in America sold from a certain date. We can debate about the date, or how quickly it'll come in, and by what percentage and so on, but they will force it. Now, what about robots? I'm a great believer in robots. I love them. Of course, I've got one like this in my home and another one that does the washing up. It's great. But what about these cars with no drivers? Let me ask a question for you. If you were offered a trip today around the streets of Boston in a car with no driver on your own, there won't be anybody from Google there with you, you'll be just getting in there, okay? It's a tour, like the duck tours last night. I hope you really enjoyed those. Those are fun. Okay, it's a duck tour with a difference, okay? It's not a duck, it's a Google, okay? And Google's going to drive you all the way around. It's a 25-mile tour. It'll take place in 3.5 minutes because they control the traffic lights as well. Put your hands up if you'd like to go and give it a go. And by the way, there will be no steering wheel in there. There's no steering wheel, no brake, no accelerator, nothing. There's just a box. Put your hands up if you'd like to give it a go tomorrow. Put your hands up if you'd like to phone a friend first for advice. Well, they're here. And, you know, Google's already run up, about 1 million kilometers in distance. It's a very successful model. But the big question is, and here's the future's about emotion, right? It's what kind of, who do you get angry with when it crashes? The driver or the software programmer? Who do you sue? Is it the owner or is it Google or the manufacturer? And that's where the manufacturers are really worried. You can see the headline, let's say Mercedes-Benz runs down a child. And say, it wasn't our fault, it's Android. What do you expect from Google? I say, yeah, but you're responsible. I said, no, I'm not. You tick the box. You say, I take Android, I press the Android button, and I take the Google Drive at my own risk. Sue the driver. And so we go around. But some of the mud would stick on Mercedes-Benz. Some would stick on Google. And there were an awful lot of confusion in a court of law, and the driver will get tangled up in the middle. This is the biggest issue to resolve regarding driverless cars. The technology, I would say, is relatively well proven now, and lots of people are doing it. And behind the technology is fantastic complexity. And you have got to hand it to these Google people. They are doing amazing things, interpreting these kind of grids of data that are constantly changing to be able to make decisions. You see two moving objects running into the road at the same time. One is a dog, one is a child. Which way does the car go? You're going to hit one. Which way do you go? Very sophisticated algorithms having to run at the speed of light. And I think that we will see whole fleets of these kinds of things, just like they take us around the airports, taking us along pretty well-described tracks. There's a kind of taxi runs or bus runs, or you just hop on, hop off. Maybe they'll come past your house. You just click a button and they come to you. So for relatively non-complicated routes that are pre-approved and the rest of it, that's where I see them coming in first. And beyond that, yes, I think the next generation will see driverless cars being used quite widely. What I really would like is a car that I can control, or rather control by thinking. And here is a human brain. This is human brain cells growing into the surface of a chip. In fact, your brain cells are programmed genetically to communicate with computers. Did you know that? I can take a sample of your brain tissue, I can grow it in the laboratory, and grow it onto the surface of a chip, and those brain cells recognize an electrical surface and they grow into it. They communicate with each other, they communicate with the chip, and they start transmitting and receiving data. We've been doing this for years in mice and rats, and it works quite well. Just recently, we had the first virtual communication between two human beings who sent a thought at the speed of light over a number of kilometers from one brain to the other without anything being involved at all. Now put up your hands if you'd like to have such a device implanted inside your brain. Oh. Put your hands up if you are definitely sure that your children should not have such things, or your grandchildren. Okay? You see, the future is not about innovation, is it? It's about emotion. It's about how these things actually connect with us, which is we're going to look at some more after coffee. But I just want to come back to this. Who owns the driver? You see, this is what it's all about. This is the heart of the manufacturing nightmare right now. I can tell you, every boardroom, they're worried about this. Is it you guys when you sell a car? Is it the person who sold them the car in the first place? Is it the telco company? Is it the software company? Is it Google? Is it iPhone? Is it the independent garage network? Is it the leasing company? Is it the software provider? What is it? I'll tell you one thing. The manufacturers want these people out. They say, well, at least take these ones out. We don't want them to own the driver. Let's get rid of them. And we can control that by making the vehicle so complicated that it is impossible to diagnose a fault without using our plug-in equipment, right? And you know exactly what this is about because you have this problem every single day trying to sort out problems in vehicles, and you have to all the testing kits, and this is going to become even tougher. They want control of the whole of the diagnostic process. They want from the moment the vehicle is sold right through to the day it's scrapped, total diagnostic power. They want to detect every fault before you've even seen the vehicle. While it's still in the car, before it's even been auctioned, they want to know that fault data going back to them through wireless networks. They want to diagnose it. They want to capture it. They want to insist that their dealer has already intervening to sort it out with their proprietary copyright-protected materials and so on. This is a complete stitch-up that they want from start to finish, but you're going to see a real fight back to stop it. Auto dealers, of course, get caught up in the middle of all of that. And we have people like Tesla who've decided they don't need dealers at all. That's interesting. Now, I just want to go back to energy because energy will take us full circle back to cars. We're looking at a $40 trillion spend in green tech over the next 40 years, 30 years or so. Now we're back to the shale gas story. Just look how the price of gas went from boom to bust just in a very few years. That meant that last year, 57 coal-fired power stations closed in the US. That meant that there was a glut of coal, which means my Vietnamese friends are building huge coal-fired power reactors, power stations, to absorb all the spare coal that there is around the world because of things like shale. In the meantime, we have enough power in the Nevada desert to power the whole of America from just about 50 to 70 kilometers by 20 kilometers of desert. We can move that power 5,000 or 6,000 kilometers without hardly any power loss using the latest technology. Photovoltaic cells are falling towards zero in price, and I mean zero. Look, that's a zero axis there. Look how fast it's fallen from 1990 to 2015. You know what produced the uptick there? I'll tell you what, government subsidies, mainly in Europe, mainly places like Germany, it meant there was a temporary shortage. But it's a relentless drive. This is computer chip manufacturing all over again. That's all these are, silicon wafers that react to light. And we'll see those costs falling so low that you'll find that the cheapest way to roof your house will be to use them. The cheapest way to put walls on buildings is to use them. The cheapest way to cover a car park is to use them. You're going to see them everywhere. At the same time, we're seeing an explosion of wind power on a scale that is totally breathtaking. The UK alone will have 30% of its power generated from wind very soon. And when you look at peak power, say in Boston, or in Miami, or in Sydney, we see a big challenge, which is you have about 4 really hot days a year when you need all this reserve power. Most of the time, it's wasted. So just look at this. Peak electricity cost in Australia leaps from, say, $50 per megawatt hour up to $10,000 a megawatt hour for just 72 hours a year. I tell you, if you've got a kilowatt you can donate into the grid at that point, you'll make a fortune. And I've got good news for you. On your car lots, you might have a lot. I'll come to that. You see, look what happened in Germany. In Germany last June, not this June, but the one before, there was so much wind one day and so much solar power, and there have been so many of these panels and turbines put up that the grid started to burn up. They couldn't get rid of the power fast enough. So the electricity companies were phoning up all the biggest manufacturers saying, hey, how many aircon units can you turn on in the next 10 minutes? Just turn on everything you've got. I want you to heat the place and cool it at the same time. Every electric heater, every single thing, every light bulb, every robot, just turn it on. It was a national emergency. Do you know what? To help them, they said, we'll pay you. We'll pay you for every kilowatt of power you can take off us, okay? You don't pay us, we pay you. We'll pay you 4 times the normal commercial rate for every watt you use. I think they thought the world had gone crazy, but that's exactly what they did. We are in the first, I said, with the first few minutes, really, of some of these innovations in cars. I tell you, in solar, it's the same. In wind, it's the same. Our world has been changed into a very, very strange place. Now, what it means is that we have times already when we have power literally to waste, we don't know what to do with, so what's going to happen tomorrow? Well, for sure, we're going to be moving this power around over thousands of kilometers, and we'll be using other things as well. And in the meantime, we've got the nuclear boom as well going on. So power storage is going to be very, very important. And now we come full circle back to you. And why is that? Well, you can store power in very expensive ways, but there's one very, very cheap way you can store an awful lot of it, which is in the batteries of 1 million cars. Just imagine a world where we've got maybe 1 million, 2 million, 3 million e-vehicles, and you know that these cars are hardly used. They drive from A to B, but when they've arrived there, they're plugged in. And when they get home, they're plugged in. So they're sitting there as a free store of power for anyone. So when the power stations are running at night, or when there's lots of wind or solar, we tank everyone up. And when there's a bit of a crisis, we take a bit out. When everybody turns on their electric kettles because the latest episode of whatever it is has just finished on the TV, we turn them back on again. And we can adjust, we can put regulations on it so we don't take more than 3% of the power from any car, from any battery. We never pull any battery down that isn't already 98% charged. Or we don't pull a battery down of a car that we know is going out tomorrow, because remember, the car knows your diary. So. But we can do these things. So in conclusion, and then we'll go into break, and then we'll look at how consumers are shifting in response to these things. What's the message? The message is that I can't remember a time in human history where we have perhaps only repeated by the first years of the combustion engine, when there's been so much innovation, so much radical experimenting going on to try, in particular, to develop new powertrains for vehicles. And so much confusion as well about which systems are going to win. But I suspect that when all that dust is settled, and you meet at the National Auto Auctions Convention of the United States of America in 20 years' time, when we look back and we saw what happened, what we'll find is this: that, gasoline, still a really great fuel. It's powering huge numbers of cars. It's just unbelievably efficient, with nanotech coatings on every moving part that in itself immediately produced another 5 to 10% energy efficiency, and so on and so on. Diesel, yes, we found ways to make it even cleaner. Diesel will still be around in 20 years' time, still be a good fuel. And alongside that, my guess is we'll have seen an explosion in the urban areas for smaller runarounds, in particular, for second vehicles, in particular, of electric vehicles. And an electrifying connectivity and intelligence across the whole lot, which means every vehicle talking to every other vehicle, the ability to switch traffic lights, the ability to swing around roundabouts, auto trading, auto swapping pieces of data amongst themselves, driving themselves, often in inner city areas and so on. It will be a very interesting and exciting time. What happens to the driver? Find out after the break. Okay, be back in 15. Thank you very much.